No, that'll create, never spray it. Oh, that's.
Okay, everybody. So if you take a look,
I know a lot.
ladies and gentlemen, let's take a look at the steps that we have here at the top. So they're printed for you, so you don't have to write them out. But it's pretty straightforward. So first, you're going to make sure that both equations are in the same form. It doesn't matter what form it is, as long as they match. Okay. If you do have any fractional coefficients, we want to clear them. We're not going to deal with fractions here. And then your goal is to make the coefficients of one variable opposites of each other. So for example, if one of them has a positive 2x, I'd love the other one to be a negative 2x. So if there's a way for me to get a pair of opposites like that, I'm going to do that. If it's already there, great. If it's not there, all we're going to do is we are going to multiply one or both, if we have to, equations by some number so that the coefficients do become opposites. Okay, so we'll do some examples of that. And then once you have that pair of opposites, you're literally going to add the two equations together. Yep. Oh, Jimmy, did you not pass them over? Let me give you one. I'm so sorry. I'm pretty sure I had counted 6, but maybe I didn't. I'm so sorry. Okay. So yes, once we have our two variables that are opposites of each other, we're literally just going to add the equations together, and that it eliminates one of my variables. Hence why this method is called elimination, because we're going to eliminate one variable, and then I'll only have one variable left. I can solve for that one and then substitute back in to find the other one. Write the answer as an ordered pair. Check it if you want. Do you remember this? This is usually everybody's favorite. So let's take a look at the first example right here. We have x plus y equals 10 and x minus y equals 12. They're both already in standard form, so I don't have to do anything there. And lucky for us, we already have a pair of opposites. You see that? We have a positive y and a negative y. So we don't even have to multiply by anything. So we're already up to step 3, add the equations together. So what I like to do, I'll just rewrite this one on top so I can just add straight down. If I add these together, x plus x is 2x, but see how positive y plus negative y is just gone. 10 plus 12, well, that's 22. And now I have this very easy equation and I can solve for x, easy peasy. So x is just going to end up being 11. Is that okay so far? Now, just like when I'm solving every other system, I need to find the other piece, right? I have x, I need the y. So where do we go? We're going to go back to either one of the originals. You get to pick whichever original you want. I'll just pick this x plus 10y, or I'm sorry, x plus y equals 10. So I'm just going to plug into an original. Now that I know that x is 11, that means y has got to be -1, right? So now I have my two values, my x and my y. It doesn't matter what order you find them in, but I'm going to give my answer as an ordered pair. Always the x first and then the y. Check it real quick in both, and it should work out. Yep, 11 minus a -1 really means plus, right? So 11 plus 1 really is 12, so hooray. Okay, now the second one is a little bit more involved, because if I look at the second example, they are at least in the same order. That's good, right? I have standard form and standard form. If it's not, I just make it so that it is. But I don't immediately have a pair of opposites. This is a positive 4x, so I'd love for that to be a negative 4x. It's not. And there's not a particularly easy way for me to get those to be opposites. But if you look at the y's, I have a negative 3y and a negative 9y. So they're not opposites, but I could easily get them to be if I just multiply which equation by what number? Angelina. Yes. If I multiply this one by negative 3, that's going to change this to be a positive 9y, which would be opposite of that. So that's exactly what I'm going to do. And when you multiply, remember, you got to multiply everybody by whatever number you're doing. So if I'm going to multiply by negative 3, which I am, I'm just going to write my answer right underneath because I know I want to wind up anyway. So negative 3 times 4x is a negative 12x. Negative 3 times negative 3y gets me that plus 9y that I was looking for. And negative 3 times 1 is a negative 3. Yeah, and now I'm ready to add my equations together. So if I just add them, I'm going to get a negative 7x. The y's cancel. I get negative 7 over here. So it looks like in this case, x is just going to be a positive 1. What do you do now? What's the next thing? Or am I done? No, I'm not done. What do I do? Angelina, go ahead. Yes, I gotta go back to one of the originals. So don't do one that you like multiplied around with. Pick an original, even though I know I crossed out part of it. So what? Just go back to whatever it was. But I'll just use this 4x minus 3y equals 1. And now I can solve for that one remaining variable. So it looks like y ends up being a positive 1 as well. And my answer on this one, I get 1 comma 1. If I check it real quick, yep, looks good to me. How are we doing? All right, because now if you check out the next one, oh, we got some fraction action here. But it's no big deal because we're just going to clear the fractions before we really get into it. So what would you multiply the top equation by? Jimmy? Say it again? 6, I agree. Don't worry about finding a pair of opposites yet. Let's just clear the fractions and then we'll worry about that. Okay, so yeah, I would multiply the top equation by 6. So everybody go ahead and do that and we'll make sure that we get the same thing. Remember, divide down, multiply up. Did you get what I got? A little bit. There we go. So multiplying that top one by 6, I got 2x minus 3y equals 6. Did you? Don't forget to multiply. Look closely. Did you put a 1 right here? I hope not, because you got to multiply everybody by 6. So make sure you have an equals 6 here, not equals 1. The bottom one, what are you going to multiply that one by? Just a 4. Yeah, if I just want to clear the fractions for now, let's multiply that one by 4. Ooh, oh, this is such a good one. I'm glad this one came up. So now I'm here, right? I have cleared my fractions. All right, great. And now I'm looking for a pair of opposites. I don't have one immediately. I also don't see a particularly easy one to get by just multiplying one equation by a number. right? There's nothing I can do. I can't multiply one equation by one number to make it the opposite of the other. So what my only choice here is to multiply both equations by something. Now, it's up to you if you want to eliminate the x's or the y's. It does not matter. It's totally up to you. I'm going to eliminate the x's this time just because we eliminated the y's the last time. So, but it really doesn't matter. Usually, if I'm looking at it, I just pick the smaller numbers. So, since I have to multiply both by something anyway. So, if I want to eliminate the x's, so can anybody tell me what should I make my x's? How am I going to get them to be opposites? Jay. Good idea. There we go. If I multiply the top by a -3, that's going to turn that x into a -6x. And then I can multiply the bottom one by a +2. And that's how I'll get the +6x for that one. So sometimes you have no choice other than to multiply both equations by a number, but that is a totally valid move. So I'm going to multiply that through. Let me see if I can squeeze that in right here. So I get a -6x plus 9y equals -18. And then on the bottom, +6x minus 8y equals 20. And now I do have that pair of opposites that I was hoping for. So now I can just add my equations together. So far, so good? Did everybody get 2 like I did? All right, now all I have to do is solve for x. Honestly, well, I don't think I would go back to the original if I'm being honest, because I would just take the original and I'd clear the fraction anyway. So I might go to where I already cleared it, but I mean, I don't know. Yeah, I'm gonna clear it anyway, so I might as well just pop it into a cleared fraction equation. So I will take the top one, 2x minus 3y equals 6. Now that I know that y is just 2. Looks like I'm going to get x to be 6. Put my answers together, x comma y. And I'll take a quick second to just check them because these don't see, especially the top one is totally doable. That'd be 2 minus 1 is 1. That's right. The bottom one's a little bit trickier to check. That would be 3/2, there'll be a 9/2 minus 2/1. So we'll call that 4/2. Yep, it does check out. I do get 5/2. Just a little bit more annoying to check because I have fractions. All right, you try the last one without me doing it. You try it, I'll try it without showing you, and we'll see if we all end up in the same spot. Hey. Oh, Jack,
Guys are bad.
do you have an answer?
No. They're
Good idea. Anybody have an answer? Jimmy, go ahead.
not sure if my X is correct, but 5 days.
You were right about your assumption.
Yeah, I just kind of guessed on the X after putting it in my head.
Well, why would you did like 90% of the work, and then the last one, you're just like, ah. Yeah, your, yeah, y is negative. Did you solve for y first?
Yeah.
Okay, yeah, that's right. Don't put it back into a fraction one, though. Put it into the one where you,
I was putting it in here. I did 5x plus -6 is equal to -1. So like,
that's right. So did you add 6 to both sides? Because then you would get 5x equals 5.
I did it in my head.
Oh,
Yeah, that's all right.
well. It's, you can do some things in your head, but you should check yourself. But I got 1 - 2. Yeah. Okay. Real quick, I do just want to show you, well, what happens if you had parallel or infinite solutions. The same thing that happened yesterday with solving by substitution. Literally the same thing. You're either going to get a true statement or a false statement. So let me give you one, not tell you which it is. And you tell me if it's a no solution or if it's infinite. So I'm just going to flip the paper over since we have a little bit of space there. And let me give you this one. Let's try. There's, oh, you can't even see it. Okay, there's one equation, and then the second one. Okay, so take a moment, solve this one. My hint to you is that it's either going to be infinite solutions or no solution. I need you to figure out which of the two it is. You may actually not even have to go all the, I guess you can find out pretty quickly. But anyway, try it. You have an answer? Hold on to it for 1 second. Yeah, once you do like the first step, you should actually be able to, especially if you're looking for it. If you know it's going to be one of these two, you're going to find out real quickly. If it's just in the mix with other problems, maybe you don't realize it right away. But hopefully you do. You arrived at your answer? All right, Zach, tell us. This one's infinite. And you get there so quickly because in your second equation, you're like, oh, I have fractions. Let me clear them real quick. So you're going to multiply everybody by probably a 4 or a -4. I might do a -4 just because everybody's negative. So let me multiply by a -4 to turn them all positive. And once you do that, you're like, oh, hey, look, it's literally the exact same equation. So once you realize that, you're like, oh, all right, so I know it's going to be infinite. Pretend for a minute that you didn't realize that. If you just kept going, right? Because some of you are like machines. You're like, oh, let me get a pair of opposites. I'll just multiply this by a -1. So when you do that, you get -x minus 2i equals -8. And then look what happens. Look what happens. Those cancel and those cancel. So what's left on the left-hand side? 0, nothing. You canceled everything out. What's left on the right-hand side? 0, it's gone. So I end up with 0 equaling 0, which is true. If everything just cancels, that is a true statement. So I have infinite. But again, you could have figured that out a lot sooner if you had noticed, oh, look, I literally have the exact same equation. Okay, so remember that's infinite. If my statement right here was not true, if it was 0 equals 7 or any other untrue statement, you guys know that would be no solution. How do we feel? Easy peasy? This is old news. Are you ready to step it up a notch with 3 variables? You are.
Literally every semester.
Good thing that I'm here to guide you. This is probably the first algebra 2 topic we've even touched. Have you done, has everything else? No, maybe you didn't do function composition.
I did this before.
This, yeah, you should have done this before. But I don't know. You guys, probably the majority of you hadn't done the function. I'm just thinking of everything we've done so far. There's not been much new stuff, right? So, okay, it's time for a little bit of new. Yes, yes. We can't stay in the old stuff forever. Your big test is Thursday. Yeah. You guys. Yes, this Thursday. The 17th.
No. I mean, I kind of had a little. I was gonna definitions. And literally off the definitions and then stuff at all studying it.
Okay, I am going to use the notebook. I don't have notes already printed for you on this. So sorry. Oops. This
Oh,
is
Sorry.
I get it, don't worry.
I don't know, today's just like a very tiring day. Already.
It's not even 9 a.m.
Yeah. I think it's because yesterday I got up at like 9 a.m. Oh.
If we get through what we gotta get through.
Guys, you need to go through so you can get Dead silence. Like, no fooling around today. Guys, I probably will be.
All right. So I think I have this as 1-11.
Oh. Oh.
All right, I'm going to simplify the process as best I can. It's not hard, it's just they're a little bit longer because you have to do, it's like doing like 4 problems in one. So it makes them a little bit tedious, I understand, but it is very satisfying at the end when it all works out. So there is a reward. All right, so we are solving systems in 3 variables. All right, so let me start you off with, let's start off with an example in front of us. So let me pick a good one. Let's do, I guess I'll do this one. Yeah, this one's a good one. Okay, so here's my example problem. Negative 3x plus 4y plus 5z equals 6. So when you have 3 variables, that means you need 3 equations. 2 variables, 2 equations, right? So same thing, if I had 4 variables, I would need 4 equations. So I have 3 variables, so I'm going to need 3 equations altogether. So take a moment and make sure that you copy them down correctly. Because if, oh, I already messed up. Sorry, I'm copying. See, I can't talk and copy at the same time. 3x plus 4y plus 5z equals 6. Yep, and then the next one is a negative 4x minus y plus 2z equals 2. And then the last one, 5x plus y plus 5z equals 28. All right, take a moment, get those 3 copied down. It's going to take me a little bit of time to walk through the first example, but then once we do one, then they're really not bad. They're just a little annoying. And I'm going to give you some step-by-steps. So your first step is easy enough. You're going to pick any 2 of the equations. It doesn't matter which 2, and you're going to eliminate any one of the 3 variables. So if I take a look here, I already see one pair of opposites. It's already there for me. I don't even have to do anything. Do you see it?
Yes.
Yeah, see how we have a negative y and a positive y? I already have them. They're already opposites. I don't have to multiply by anything. It's already good to go. If I don't have that, usually you do, but if you don't, then you just do like we just did, multiply one of the equations by something so that you get the pair of opposites. So step 1, I'm going to choose any 2 equations and eliminate any variable. So for our purposes, we're going to use the second and third one, and I'm literally just going to add them together. So I'll just rewrite them here. Negative 4x minus y plus 2z equals 2. So the y's are gone. What I like to do, once I have once I have combined 2 of my equations, I like to star this one and put some symbol because I need to come back to this equation later. And it's just so much easier for me to find it and to, especially to talk about if I just say, oh, the starred equation. So you know which one I'm talking about. So I'll even add in my step, star that equation. If you don't want to use a star, you can use a happy face. It does not matter. I'm like putting a sticky note on that one, just so I can find it easier later. Because now I'm gonna leave that alone for a minute. I'm gonna go back to my 3 originals. There was one I haven't used yet, right? In this case, it's the top one. So whichever one I haven't used yet, here's the trick. I have to use that one. I'm going to pair it with one of the other 2 I've already used. It doesn't matter. But I have to use the one I haven't used yet. And I have to eliminate the same variable that I eliminated the first time. So I eliminated y. So now I'm going to have to come over here. I have to use the top equation and I have to eliminate y with someone else. So I personally would do the middle one, right? Because I could take the middle one and just multiply it all by 4. And then I would get that pair of opposites in the y's. Do you see that? So in step 2, I need to use the original equation you haven't used yet. And eliminate, and this is key, the same variable. It doesn't matter which of the 2 other equations I reuse, just use whichever one makes more sense. So let me give you a moment just to get there. All right, so now let's try it. I'm gonna take that top equation. So I'm just gonna recopy it down here. Negative 3x plus 4y plus 5z equals 6. And now let's take that second equation, but times it all by a 4, right? To get those y's to cancel. So I'll even put second equation times 4. Just to remind myself of where that came from. And that's going to be a negative 16x minus 4y plus 8z equals 8. Let me know if I have lost you or if you're feeling okay so far. Because now after this, it actually gets kind of easy. But I need you to be okay with like where I'm getting all of this from. Have I lost anybody? We're all still okay? You're with me? And now I'm just going to add these two, right? I just want to combine these two. So let's add these two equations together. So that's now going to be a negative 19x. The y's are going again. What's that? 13? Once you have combined these and created this new equation, I'm going to star that one. Because now from this point on, it basically is almost the same as what we've already been doing. You're just going to use your two starred equations. So if you look at the two starred equations, look, they both only have x's and z's because you already got rid of the y. So now you're down to a two variable system. So now you're going to solve that one the way that you already know how. So I'm just going to look. I don't already have a pair of opposites, but I can get one and then I can just solve from here. It's just getting up to this step. Does that make sense? So now I'm here. I'm down to a two variable system. So in step 3, I'm going to just solve the system of the starred equations. Oh, I forgot to write after step 2 to star that one. Star this one, 2. And I mean, the starring is just my way of making it easy for me to find them again. But you could literally do whatever you want. You don't even have, I don't know, it just helps me to find it on the paper. And now I know what to do from here. Okay, so solve those two, the starred ones, however, and you could switch it. You could solve by substitution now if you wanted. I always just stick with elimination, but you can do whatever you want. So I'm just going to solve these two. I'd probably multiply the top one by 19 to get my x's to cancel. And we're going to keep our fingers crossed. All of these are supposed to come out nice. They're all supposed to be some kind of an integer. So fingers crossed that it works out that way. In the real world, of course, that may not always happen. So I'm going to do I'm just going to recopy them here. I like to have my notes as clear as possible. I'm going to take this top one and I'm going to multiply it by 19. 19 times 7 is 133, if you're wondering. Here's like the moment of truth. It's 584 divided by 146.
Yeah.
It's a whole number? Oh, What is it?
4.
4. Oh, that's always such a relief. Because it stinks to do all this work and then it doesn't come out nice. And you're like, are you kidding? There's like one mistake somewhere in there. And now you got to go back and find it. It's crazy. So I will tell you right now that all the ones that we do in this class, all the numbers should come out as an integer. So you should not be getting any decimals or fractions for either X, Y, or Z. They should all be some kind of, it could be 0. 0 is an integer also. But they're not going to be fractions or decimals. So if you get fractions or decimals, I'm telling you right now, there's an error somewhere. In the real world, of course, you could get fractions and decimals, but I'm not giving you any. They should all come out nice. All right, great. Now it is a little bit different because again, think about when we solve a normal system, that's 2 variables. Our answer is X comma Y, right? Now I have 3 variables. So my answer is going to be X comma Y comma Z. So I need 3. So it's not an ordered pair anymore. It's an ordered triple. So I have the first one. I know what Z is. How can I figure out the others, do you suppose? Exactly. Go back to one of your start equations. And can I find, if now that I know what Z is, I can find what X is. And then once I know what X and Z are, I can go back to an original to find Y. Okay, so there's my next steps. I didn't really leave myself any room to continue writing those steps. I'm so sorry. I will jump to it down here. So we are just going to take that answer, take answer, and plug. Oh, this pen is dying and it's my best one. Okay, we will try. Oh, I have a blue one. The blue should be great. Oh, and I didn't mean to write answer again. I meant to write into. So I'm going to take my answer and I'm going to plug it into one of the 2 start equations. It doesn't even matter which one. I'll just do the X plus 7Z equals 30 because those numbers are smaller. Now that I know that Z is 4. Great, I have 2 of my 3 answers. So now go back to any original and plug in the 2 that you have to solve for the last one that's missing. So that'll be step 5. Take those 2. And plug into an original. Any original you want. I'll do the bottom one because everything's positive. But again, it shouldn't matter. You can do any of the 3. Oh yeah. Did you guys get what I got for Y? Okay. So to finish, just like when we're doing a normal system and we write our answer as an ordered pair, we're going to write this one as an ordered triple. So you got to make sure you have the X first, then Y, then Z. Okay, so that's our last step. Write answer as an ordered triple. So for us, the final answer is X was 2, Y was -2, and Z was 4. Woo! So do you see what I mean about they're not hard, they're just, there's so many pieces. Bless you. And unfortunately, that means so many opportunities for you to drop a negative, to misadd. They can get very tedious. There is only one on your test, and that's it. And I'm telling you right now, they come out nice. Let's try another together, shall we? And let me do you one better. I'll give you the worksheet so you don't have to copy it again. The one that we just did is number 4 on here. So I probably should have given this to you already, so you didn't have to copy that one down. Sorry. Sure, it was so fast. Yeah. Oh, yeah, you never win. Go so fast, oh my gosh. There are 6 in this pile. 6. Counted twice. All right, so we already did number 4. So I'm just going to jot down the answer there so we don't do it all over again. 2, -2, 4, we said. By the way, you can check this answer. That triple, you can plug into any of the 3 originals and it should work. So that's another one. Before you turn your test in, plug it in and make sure that it really does work so you know that you have the answers correct. All right. Does anybody see another one? It really doesn't matter which one we do. We can do any of them. Anybody have a preference? 1, you got it. All right, let's take a look at number 1. So step 1, I want to get, I'm going to just pick any 2 equations and solve any of the 3. Get rid of any of the, oh my gosh, there we go. Ooh, this one's actually really good because take a look. I already have the C's as opposite in the first 2. You see that? So let's just take the first 2, add them together, and we can eliminate C. So if I add these 2, I get 3A minus B. C is gone. -2. So I'm going to star that equation. So far, so good. Now, the second step, I have to go back to the originals and I have to use the one that I didn't use yet. So in this case, that's the bottom. And I have to eliminate C again. Hey, we luck out because if I just pair the bottom one with the top one, the C's will cancel. So let me do that. So I'm going to do the top equation, 5A plus 2B plus C equals -1. And I'm going to pair it with the bottom one. And I have to use the one that I didn't use yet, which I am. And I have to eliminate the same variable, which I am. So did you get what I got for the second one? So I starred them both just so that I can talk about them more easily because now my 2 starred equations only have 2 variables. I'm just going to solve that system, right? So that's old news. So everybody go ahead and solve the system formed by those 2 starred equations. sometimes I write myself a little note of how I got to where I'm going. So I'm gonna take my top one and multiply by, oh, I should do by -2. But you could have eliminated the B's too, it doesn't matter. And then when you see that that first number, the first variable that you're solving for is gonna come out to be an integer, it's definitely a sigh of relief.
Wait, so what if I found one and you found one? Do we have to find the other one? Like I
Well,
found-
you have to find all three.
Well, I found A and you found B. Like we already found. We found C.
We will, yes, but you gotta find it. You should be able to find all three. Yes. We can't do all of them as group projects, I wish. Actually, no, I don't, because every group project I've ever been in has not been great. Because I always do it all. I get frustrated. Are you guys in that same boat?
But then you learn.
Oh.
Did I learn the most? I learned that I hate group projects is what I learned. When I went to Costa Rica for 2 months, I did a whole semester of college on an advanced project with 2 other teammates. It was awful. It was probably one of the worst academic experiences of my life. And I'm like, this is, huh? No, because everybody had to get the same grade. Yes, I'm to the, this has been, gosh, where am I at? It's literally almost 20 years later and I'm still mad about it. So I'm not big on group projects, but anyway, don't let my bad experience soil you, but they can be great. I've heard good things. Just not me personally. But anyway, all right, so there's B. Now I'm gonna go back to one of the 2 start equations. I'll pick the top one. Careful, minus a negative, right? I'd have minus -1 if you're gonna solve it the way I am.
Wait, so what are you doing to find
After you found the second one.
No, the first one.
So now, once you have one of them, you go back to one of your 2 start equations. Either one you want, and then you solve for a second variable. Once you have 2, now you go back all the way back to an original. Pick any original you want and plug in those to find your remaining one. Hello,
Hello, Miss Savia. How are you?
I'm so good.
That's
They
good.
are loving solving systems in 3 variables.
Good times.
They didn't know it could be this fun.
Other than that, to be honest with you. Imagine if we could do 4 variables, 4 equations. Hot dog.
The things up us.
Good times.
But now you actually could, right? You just do the same things. So it'd just be that many more pieces though. Anyway, I got -1, -1, 6. Did you?
What did you get?
-1, -1, 6.
Yeah.
Oh, yeah.
So this wasn't XYZ, right? It's ABC. You always put them in alphabetical order. So if it's not or XYZ, just put it whatever the alphabetical order would be. Okay, we're gonna do 1 for homework. Which one should we do? 2? 2? Everybody's leaning towards 2?
Sure.
Yeah.
Sounds good.
Yeah, but like, I don't.
2 is actually really
Can I
hard.
do it like? I can't.
All right.
I don't know what birthday was right now.
But number 2.
Number 2.
Alright. I circled that. I'll do it later. I just.
You can do it right now. Just gotta be speedy. Let me open it up on Jupiter. Give me just a minute.
Happy birthday to my best friend and all.
Happy birthday.
It's like this snap of a happy birthday. Those make
Oh,
me
this does
mad.
work
You
out.
see the one where it's like, when people are like, happy. Oh, yeah, I do those guys. Wow.
I've already done through those.
Well, I did it once.
Once.
No, but you know the people that are like, happy birthday, to my friend. They're like, happy birthday, you're so funny, like, they're so funny, love you. You don't even have to.
You stand your story.
Yeah, well, like, because I love my friends so much. No, but, you know, the people
We're
that
just
are
gonna watch it, like,
HPD actually.
I love when you do that, it's so funny.
Well, I did do it, and then.
Does it
I
stay-
did happy birthday.
Yeah,
I told you.
of course you can.
No, but, you know, the people that are like, happy birthday, and then like, I know they're rude, they're like mean, so they're like happy birthday, and they hate you, and better not do that.
You just do what?
Happy birthday,
Wait,
you're so ugly, I hate you so much. Wait, there are, you know, people that do that though? And it like actually makes me laugh. Like, I really, some people that do that.
I don't know how girls do this, I don't like this stuff. I feel like it's good.
Those ones.
On me.
Is it possible for 80 to 0?
Sure.
Okay.
Oh my God, Jill.
Yeah, guys, just like yesterday, don't get thrown off if one of your three variables ends up equaling 0. They could cross at 0 comma whatever.
Oh my God.
You have to do them all.
I do?
No, I'm kidding.
Wait,